Alright everyone, I'm back here with this problem that we left off with. So we were trying to find the limit as x approaches 1 for this function right here, or expression. And if we do direct substitution, here we see that we get 0 over 0, which doesn't work in helping us find the limit. This is indeterminate, and whenever you guys get 0 over 0, then you're going to need to use one of the techniques that we're going over in this section. So we're going to use the dividing out technique again, just as an example 1, to try and get this to factor and divide out some factor. So what I'm going to do first is I'm going to go ahead and factor out the denominator here. So the denominator, I'm going to go ahead and factor by grouping. So x cubed minus x squared, I'm going to group those two, and then x minus 1, I'm going to group that. So right here we see that we can factor out, or we can pull out an x from this right here, or actually an x squared. So we can pull out an x squared, and we're left with x minus 1. From here we can't really factor anything out, so we're just going to leave it as x minus 1. So now I see that I have x minus 1 and x minus 1. Think of this as a common factor, so I can factor out this as well, and I'm going to be left over with x squared plus 1. So that represents this x squared times this, and right here we have, in a sense, we have 1 times this, right? So my x squared plus 1 comes from this x squared and this 1 right here. So if I multiply this, now I factored out x minus 1, so that's the common factor that I pulled out. So now notice that if I were to multiply this times this and then times this again, I would get this up here. So that's essentially showing you what I did here. I just factored out the x minus 1. And now that I did that, I can rewrite this limit as x approaching 1, x minus 1 over x squared minus 1 times x minus 1. And here we see that we can divide out the x minus 1. In this book they call it dividing it out. You guys think of it as canceling, but dividing it out is a little bit more appropriate to talk about, because canceling, usually people think that it just goes away, where it doesn't. This is just being divided out. So now that we have this, we can actually now go ahead and try direct substitution. So we have up here, just keep in mind that we don't end up with nothing or 0. This actually, there's still a 1 up here. So this is really the limit of x approaching 1 of 1 over x squared minus 1. Now we can try direct substitution. So we're going to plug in 1, and we're going to see that we get, just a second here. Oh, hold on. Oh, let me go back, because I see that I wrote this. So from here we see that it's x squared plus 1. I wrote this wrong right here. It should be x squared plus 1. So this should be x squared plus 1, x squared plus 1. There you go. So this ends up becoming 1 over 2. Okay? And this is our limit as x approaches 1. Alright, so I'll give you an example. Go ahead and try it out. So this is the limit as x approaches 2 of x minus 2 over x cubed minus 2x squared plus 2x minus 4. Alright, so for this one, just keep in mind what we did before. We have a cubic here. We have the x cubed term, the x squared term, the x term, and the constant. So see if you can factor this out by grouping. So group these two first, and then these two, and see if you can find a common term to factor from each of them. Go ahead and pause the video and try it out, and then come back to it and play it, see if you see what you get. Alright, so here we're gonna go ahead and try and solve this. So for this bottom part, first of all, let's check and see if we can do direct substitution. If we get 0 over 0, then we're gonna have to use the technique that we just talked about. So I'm gonna plug in 2 into my numerator, 2 into my denominator. Up here we get 0, down here we get 8. Squared is 4 times that minus 8, so it's 8 minus 8, that's 0. 4 minus 4, that's 0, so it's 0 over 0. So now we see that we can't use the direct substitution. So let's go ahead and use the dividing out technique. So for this problem, we're going to start by factoring the denominator. So x cubed minus 2x squared plus 2x minus 4. I can go ahead and group, and I can see that I can factor out an x squared from my first group here. So this would be left with x minus 2. And from here I can factor out a 2, so I would have a 2, and then I'd be left with x minus 2. So here's a good thing, we have x minus 2 and x minus 2. I can factor out x minus 2 from this whole expression here. So I'm going to be left with x minus 2 times x squared plus 2. And now that we have this in factored form, I can rewrite this as the limit of x approaching 2 of x minus 2 over x minus 2 times x squared plus 2. So now I see that I can divide out the x minus 2. I'm left over with 1. So now I can just do direct substitution for this expression here. So it's going to be 1 over 1 squared plus 2, which is going to be equal to, oh, I'm sorry, not 1, but 2. Remember that we're taking the limit as x approaches 2, so I'm going to plug in 2, and that ends up leaving me with 1 over 6. So our limit is 1 over 6. Alright, well, after this video, you can go ahead and use the dividing out technique. On my next video, I will be using the rationalizing technique, so I'll be bringing that up in a bit.